Hello and welcome to another Solidworks tutorial by me, NASA. Today I'll be focusing on creating surfaces. Two types we'll be looking into. We'll be looking at bridging surfaces, so creating smooth transition between surface A and B, whereby we can call it a bridging surface, or surface A and surface B. Okay, you've got two edges running along the surfaces and connecting those edges between one another and creating this smooth, seamless join or bridge between them. The second type we'll be looking at is where we have a boundary or bounding surfaces A, B, C, and creating this, if you like, a hole or void in the middle, and bridging that void together. You might come across this type of surface known as a patch or patch type surfacing or surface patches. Either way, let's get straight to it and I'll show you what I mean. Okay, so in Solidworks I've created two surfaces. If I switch the planes off, make it a bit clearer. I've created two surfaces, one planar surface, which is a flat 2D planar surface, and one curved surface, which is created using an arc. So our goal here is to bridge between a fairly simple arc shape or edge surface, and then bridge from there back down to a simple flat planar surface with a straight edge. First thing you'd need to do is find an appropriate tool. Over on the Surfaces tab you'll find various tools that can help you achieve this blended or bridged surface between the two surfaces. The one I'll show you today is the Lofted surface command. So if we head over to the top toolbar under Surfaces and click Lofted surface, the command will activate, and on the left side you'll be presented with a tool properties or feature tool manager. For the first one, we'll select the edge of the curved surface facing the edge of the planar flat surface, and that will become our second edge. Once you select those two edges, Solidworks will automatically give you a preview of the surface, as you can see there. Now if yours does not look like this, then you probably have some of the following things going on. If you see nothing at all, you probably have a twist condition, whereby Solidworks has detected, as you were clicking along, Solidworks detected that it should start from one point on one edge and end up on another point on the corresponding edge. Simply correct that by right clicking and clicking on reset connectors. If that fails to work, simply drag one of the connectors on one of the edges to initialize that lofted surface, and it should appear as so. The other thing you'll notice on my one, I've got a mesh showing across the surface, and this is under your curvature display options within the Surface Loft command. You can toggle the mesh preview and the density of that mesh to give you an idea of how that surface is flowing, and an even better way is to turn on the zebra stripes, allowing you to look at that curvature and how effectively light will fall across that surface, allowing you to really analyze and get closer to the surface on screen. So we'll click OK to that for now, just to understand what this has given us, what SolidWorks has generated here. We'll click OK. And we've created a bridged surface, but as you can see, this is a fairly primitive effort, to be honest, and not really what we're after. Remember, we are after a clean, smooth surface transition between our first arched, curved surface going straight towards a flat planar surface. So one of the ways we can look at what we've actually achieved here on screen is to click on the Evaluate tab on the top toolbars, and we can use the curvature tool to assess how the surfaces are curved, or how much they curve, if anything. And we can use also the zebra stripes across all surfaces to show how the surfaces blend between each other. So as you can see here, with the surface overlaid with the zebra stripes, we can see we have the curved surface, light effectively traveling in straight or curved lines, blending into the following surface, our new bridged surface. The lines are discontinuous at this point and not flowing very well. And again, on this last transition, we see, to be honest, a very poor transition indeed. I'll toggle that back off and turn on the curvature tool. We can see a clean, simple color on the curved surface, indicating there's a consistent curvature across that surface. Then we fall quite drastically into a different color, indicating different curvature, and then it's finally we reach a curvature of 0 for the flat planar surface. This all makes sense, but this is certainly not what we want. So the way to resolve this is to simply go back into the surface loft. So right click on the surface loft, either on the feature tree manager here in the history, and click edit feature, or you can go directly onto the surface loft, right click on that and edit the feature from there. Once you're going back into edit mode, you'll notice a start and end constraints drop down menu. Now we can actually set a start constraint, so we can give it a little helping hand, if you like, as to how SolidWorks should treat that edge or that surface exiting from the edge that we've selected. So remember, this is our first edge that we've selected, and now we're saying this is our start constraint. Now there's a few options here. A direction vector is a vector or a direction from which we can start our surface lofting. You normally need an extra sketch for that, so we'll pass on that for now. Another one you have is a normal to profile. This is literally normal. This is a surface being extruded, lofted normal to the edge and the surface that the edge belongs to. So The other one is a tangency to face and a curvature to face. Again, it's using the face as a guide. Now, as you can see, once you select a type of constraint, I've selected a normal to profile constraint here, and left everything as default. And then we can apply, for our second edge, we can apply another constraint, and we can say that we're only given two options here, a tangency or a curvature to face. A tangency should be fine here, and you can see what Solidworks does in applying a constraint to the lofting or lofted surface. If we click OK to that, to accept and have a closer look at what this has done, already that's looking a lot better. But we'll use the evaluate tab and tools found with the zebra stripes, and you can see that is a lot better. We are achieving a significant improvement in lofting between the curved surface coming out of the curved surface to our bridged lofted surface and down to our and that's coming clean, and down to our planar flat surface. We are still experiencing clearly a very distorted result for our curved or bridged lofted surface to our planar surface. We are still experiencing a distorted sort of result. As you can see, the lines bouncing off there don't quite meet up correctly. We're still not getting a perfect result from our curved surface either. If I switch that off for a second, turn the curvature tool on, and you can see a nice color transition between the curved surface over to our bridging surface. There's some distortion there, it's probably a little bit of a twist, and we are also getting a very abrupt transition between our bridge surface to the planar surface. So there's an abrupt end, so that sort of explains why the zebra lines were not transitioning clean between the two. If we switch that out for a second, there is another way we can further improve this. So if we go back into edit mode for that surface loft, so right click on the surface, click on edit feature, and now we can look at applying tangency between the surfaces, and you can see there was a slight pullback as soon as that happened. So if I click back normal to profile, and if you look carefully at the center of the screen, the surface itself, you can see a slight change in the surface as we make the selection. Tangency will certainly improve the transition between the curved surface coming out into the surface loft, and the end constraint we can apply a curvature to face, and see if that changes things. And you can notice a certain change happened in the zebra stripes there as I clicked that as a condition. Let's click OK, have a closer look, and on the face of it, it looks almost similar to what we just had, but as you will now see, after we look at applying the zebra stripes, we can see a clean transition between the curved surface, which has certainly improved, and a much better transition between the surface loft and planar surface. If I now select or deselect the zebra stripes and select the curvature tool, we can now see a cleaner blend from the curvature to the surface, and from definitely the surface loft to the planar surface. As you can see there, if I give a top view, you can see how nicely the curved surface blends into the flat planar surface with a change of color and curvature as it proceeds closer towards the edge of the planar surface. Okay, so the next example is a surface or multiple surfaces creating a void in between the surfaces, and then we have a set of boundary edges that are formed between the surfaces. Now you've got two options here, possibly more, but the common ones people often decide to do here is create a filled surface, selecting all the boundary edges within the void. So I'll just demonstrate that now. So we'll select each one by one, and you can see Solidworks will slowly start to build a preview as you go along. Now you can't completely see how well this is behaved, but you get an idea that there's general agreement with the surrounding surfaces for now, from what we can see, and we can change the contact settings to curvature to see if we can achieve a clean blend between the two. We'll click OK and see what result we get, and click on the Evaluate tab at the top, and we'll click on curvature, and you can see whilst we've got a good blend between the original surface, surrounding surface up here, and the color and gradient curvature changes nicely in between, and the same goes for the lower surface, where we get a nice consistent color of curvature through there. The real trouble occurs in this middle region here, the intersection between the two blending surfaces. Now if we were trying to achieve a better blend, and certainly you'd have to achieve a good blend for aesthetic and consumer products, perhaps you're trying to achieve or capture certain organic geometry correctly, we'd need to improve the method here. So if I turn the curvature tool off, suppress the surface fill for now, and see if we can achieve a better result. So one way to look at this is to not simply try and fill any void using the filled surface as a first port of call. The best way to think about these sorts of problems is to see if you can do this stage by stage. So for example, I've got a surface here and I've got a second surface here, and that's creating our void in the middle, whereby we actually truly want to rebuild each surface in its completeness before we even think of joining the two. So I'm going to concentrate on rebuilding that first surface above here to see what we can achieve. The other thing to note just before I do that is if you click on the Evaluate tab and have a quick look at the curvature feature, plot, we can see without cutting this away, we'd have to achieve a blend between the two. So to begin with, we'd have to try to reconstruct the green patch correctly, and then this lime olive green color surface correctly, and then we have to do something in the middle whereby we create the perfect blend between the two. So let me begin by creating a surface loft. Yes, a loft between the two, so we can achieve the correct blending between each surface, or at least a new patch surface within an existing surface. So I'm only going to concentrate on this upper surface. If I turn the lower one off for now, so it's a bit clearer what I'm trying to achieve. Click on the Lofted surface command at the top. For the profile, I'll click on the profile edge here where I've got small curvature and the opposite curvature, and Solidworks will try to fit or show you a preview whereby it can fit the perfect curve or arc through that surface, just to indicate what the mesh is doing here. And then I'd use a guide curve. I'll use the existing surface curve or edge to give me an alignment between the loft there. Click OK to accept, and we'd check to see how well that has occurred by clicking curvature, and you can see straight away we've got a really nice blend all the way to from start to finish here. In fact, if we turn the zebra stripes on, we'd see a really nice clean blend between the two. So here we're happy with what we've achieved. We'll turn the other second surface on, effectively do exactly the same that we've achieved with the top. So we will create a surface loft, select our first curved edge, and then select a second curved edge, again doing almost the same thing in reverse really with the other surface, and then selecting the curved the edge as a guide curve for that loft, and accepting OK. And then if we have a quick look at what this is doing, you can see that's cleanly copied and given us the blend we were looking for between the new patch and the existing surface nicely as well. So you can see there's a nice blend between the existing patch and the new patch we just created. However, there is still not there's still a problem, as you can see there, between the surfaces, the major surfaces, as you're trying to go between the two. You can see that's very visible using the zebra stripes there. So let's see if we can solve this issue next. So to begin, first I'd look to knit the two surfaces that we created, merge, click OK, and that will give us one surface to work with. And then the other surface we can do the same, so surfaces, click on knit surface, select the two patches, knit the two, click OK. And now remember, the goal is to create a clean blend between these two major surfaces that we created. So we'd have to cut or trim the surfaces back to create a new bridged surface between the two. So that's the typical workflow you'd be looking to try to create. So we go from this olive green color through to the darker green in a nice smooth transition, rather than this abrupt occurrence here. To do that, we'd have to trim, as I said, trim the surfaces. So we'd create a bounding region here, so we can use that as a trim tool. So give it a good size so we can have a good proportion of the blend occur within the region we're trying to blend. So this is let's say 15 mil, about a third the way. We'll center this just so it's covering the complete surface and there's no doubt about that. Let's just say, let's place it, let's just place this offset, make sure it completely goes past the surfaces. And once that's done, we can use this to trim back the existing surfaces using the trim surface command. Place the trim tool, the sketch that we've just created, as the trim tool. Click on remove selections and remove the connecting join of both surfaces, and remove that completely. So now you end up with a void in between the two surfaces, but the prospect of being able to join everything in a much more smooth manner. So let's head over to the Surfaces tab, click on Lofted Surface, select the profile. The first profile we'll need to right click and select Selection Manager. We'll click on each of these edges and turn it into one continuous edge. Click OK, one continuous open group of selection, and we'll do the same to get the corresponding edge. Click OK, and Solidworks has placed the surface. You can see it's fairly linear at the minute, but if we give it our start and end constraints, we'll try tangency to face for now to see how well that behaves. Click OK, and we've got a surface there, and if we turn on the curvature plot, you can see whilst there's a transition, it's probably not the best result, although it's not too bad between the surfaces, although we do still have that challenge in the middle in some at some angles. So let's go back and see if we can improve that. Okay, so what we can try here is to click, see if we can rebuild this segment by segment. So use tangency to face, curvature to face, curvature to face. Click OK. Now let's see what we've got here. Got a very good transitional blend there. It's much more linear in the middle, which is great, and then we've got a nice transition between the two. That's looking very good. And then we'll add, and we'll have a quick check of the zebra. That's looking a lot better between the two. And then we'll rebuild this last one, and then we'll create a loft between the two. We'll use the edge, adjacent edge there as a guide. Click OK. We'll just have a quick check here. It's not transitioning well between these two surfaces. So we can see if we can create a tangency to face condition across this area, and we'll have a quick look here. That's looking better, and then hopefully we'll have a decent transition between the two. Yes, we do. And then we'll create another surface going from this end to that end, and then we'll use the guide curve on the inner edge here, and we apply a tangency to face condition on the inside, and there you have it. We'll knit everything together. We'll create a merge condition, and we'll make sure there's no gaps in between, and that's merged everything together. And then we'll hit the curvature plot. That's giving a nice transition between the two, and you can see the zebra stripes really blending in nicely between the two. Turn the edges off and just so you can see everything really occurring the best as it can. As you can see, the idea of surfacing is to rebuild surfaces, perhaps create smooth blends in the right way. It's not always a case of throwing or slapping on a patched surface, or what we were looking at here, which is a filled surface. Is sometimes the better treatments are to actually do the work and create multiple surfaces, trim back where you need to trim back, and achieve what you're looking to achieve. So if I run through this, we had a loft, we rebuilt the center, let's just have a quick recap here. We created a trimmed everything back, created a surface, knitted everything, trimmed everything back, lofted in the center because that was the largest surface transition, and then we created a surface patch on the left side and on the right side, added the tangency conditions between the inner edges, and then we knitted everything together to give us that one surface body that's blended as nicely as possible, that we can achieve better aesthetic surfaces.